Okay, the key thing we're learning today is important for when we want to convert Macaulay's formula in gravity to that of, a different axis of the Earth. So, without getting too much, the key is a similarity transformation. Similarity transformation. So if you remember back to, this will be in your linear algebra. So out of that, if you remember, what's interesting is just when you want to diagonalize an inertial matrix, you have a generic, you can do it via the similar matrices, if you remember that. So the key for the moment of inertia about a given axis, so if we write that given axis as, a unit vector in space, right? So then we know that then a new inertial matrix will be given by a similar, the unit vector dot, the dot product's important there. The inertia diagonal will say, it's already diagonalized in our case that we want to look at, dot the unit vector. Note that this does not have to be diagonalized in general. So if we let the direction cosines between these two axes, so we've talked about that before. So if we label them, so the direction cosines, let's label them as alpha, beta, and gamma. So that way we define the direction of that axis relative to our, generic like O frame, if we want to origin frame. It's just the typical vector you see, alpha I hat plus beta j hat plus gamma k hat. So when we plug this in and do the math, so let's just do, first in hat dot, and let's do this matrix. So this is, remember we're going to use, we've already gotten diagonalized for the principal moments of inertia. So I can write it just the diagonal, the moments of inertia. Now we're going to be dotting or multiplying by this matrix written in vector form. Could be given like this. Cool. So that means we have, this is also given by alpha, beta, gamma, dot. And if we do this matrix multiplication here, we are left with the vector ixx alpha, iyy beta, beta, and izz gamma, which, doing this dot product and noting the scalars here can all be rearranged, gives ixx alpha squared plus iyy beta squared plus izz gamma squared. Ooh, I can't draw boxes. Cool. All right. So I think what we have to do is we have to review what is and how did we get to the proof of the similarity transformation back in linear algebra. Will help us understand why this relationship will hold.